In this lesson, we're going to focus on non-blocking I/O. I'm going to start with a very quick demo with JavaScript. So I have my Chrome browser open, and I have the URL set to a file called block.html. We'll look at that just in a moment, but let me run the demo now. So as you can see, a JavaScript alert pops up telling me that this is right before a blocking call. And then I get another alert notifying me that it's right after a blocking I/O call. So let me show you the HTML. You can see it consists basically of embedded JavaScript and little else. Line 3 is the critical line for us. I'll highlight it here in the browser, but we'll look at it more closely in the working file in just a moment. So you see there a call to local storage.getItem on the right-hand side, and that's a blocking I/O call. So we'll use that basically to contrast it with code that does non-blocking I/O. So let me bring up that working file. This is my Emacs editor, and the name of this file is nonblocking.txt. So let me now focus on the code that we just saw in the browser. Here it is, and it's very simple JavaScript. So let me go through this rather quickly. So at line 1, I set local storage.name. If you've not used local storage, it's basically a cache that JavaScript provides for you. .name is arbitrary. I could have called this anything, and I'm setting that to Flintstone. Then I'm doing an alert, just so it's easy to follow what's going on. And then here's the important part for us. I have a call to local storage getItem name. So I'm referring back to the key that I introduced up at line 1. And the important point for us is that nothing happens here. And what I mean by that is line 4 does not execute until local storage getItem name returns. Now it could return successfully. In this case, it's going to. It's no big deal. But either getItem is going to return with success or an error is going to be generated. In any case, the second alert is not going to execute until getItem returns one way or the other. So line 4 waits, in effect, until line 3 completes. Or in the jargon that we're using, local storage.getItem is a blocking I/O call. Now the second example is going to be in pseudocode, not in JavaScript, for technical reasons that we'll get into a bit later. So the pseudocode is straightforward. I basically define what I call callback function. It takes one argument, which is an HTTP response. We're going to assume that this is properly formatted and so forth. We don't care about the internal details. And I'm also going to assume that I have a function called extract product list from response. And what it gives me back is a product list that's appropriate for printing. And then I print it here. As you can see, my indentation is a little bit off today, so let me fix that on the fly. Okay, so callback function is going to be called from the code below. So in the pseudocode, what I do first is to set a URL to some fictitious resource. I get the connection with that URL. So again, this is just fictitious for our purposes. Our emphasis is on the blocking versus non-blocking aspect of this. And then at this line, I call fetch. What I'm doing is I'm asking the system to go off machine, to fetch some document and to return it, but I don't want to wait at the fetch line. So instead, I provide an argument, which is a callback function. So what I'm telling the runtime in effect is this: return immediately from fetch, but go off and do the fetch, and when you have something to report to me, call my callback function way up above. So again, that's the callback function. After all of that is done, we print hello world, and then for good measure, we do a second print as well. Now here's the point that I'd like to make. Here's the challenge and the complication of non-blocking I/O. It's unclear exactly what order things are going to print in. Now I'm assuming that the print hello world is blocking. In other words, nothing's going to happen until hello world appears on the screen. After that, goodbye cruel world, which is also a blocking call, is going to output that message to the screen. The real issue is, where does this print occur? Probably it's going to occur after the other two prints, because after all, we're going off machine. We have to do some processing, extract the product list from the HTTP response and so forth. But basically, this is a guess. Maybe an educated guess, you could argue, but it's still a guess. It's possible that if that URL business occurs very quickly, the connection is set up, the document is retrieved, it's possible in principle that the print product list could be the first print followed by the other two. Or it may happen that print hello world occurs followed by print product list followed by print goodbye world. So even this very first pseudocode example gives us a sense of the challenge that comes with non-blocking I/O. To be sure, there's efficiency because, for example, we call fetch, but we don't wait around for fetch to do something with success before continuing. We call fetch, we continue on our way, and then if fetch returns with success, we're able to print at some point a product list.